Okay, this is Chapter 6, Major Ecosystems of the World. The information that you're going to get in here is background information. You're not necessarily going to be asked a question that says, which biome is this? You're going to be asked questions that require you to know what the characteristics of biomes are. That's why I'm having you do the biome chart as well, so you have that information kind of as succinctly as you possibly can. The first thing we're going to look at with biomes, terrestrial biomes, is what I'm going to be lecturing on videotape. I'm going to do the aquatic biomes with you in class. But lecturing, first I want to talk about fires, because inherently we've talked about how fires kill ecosystems, has to go through succession and rebuild again. But wildfires aren't all bad. And wildfires that are not really, really hot actually do a service to an ecosystem. It returns nutrients to the soil. It actually gives the soil a nutrient dump. So that all of a sudden there are lots of organic matter. There's nitrogen and phosphorus that are in here, and it's very, very good. It helps the ecosystem to regrow much more quickly. Also, there are some pine trees, such as the jack pine, that hold their seeds until there is a fire. Why? Because this guarantees that there's plenty of nutrients in the soil for those seeds to germinate. Something bad, it can increase soil erosion, but normally when a fire goes through an area, even if it's grassland or trees, grassland, the fire's not going to bother the roots unless it gets really, really hot. But it won't bother the roots, so the root system is in place to hold the soil. And many trees have fire-resistant bark. And there again, unless the fire is excessively hot, the fire will just go through, it'll scorch the trees a little bit on the outside, making them black, but it won't hurt them. However, if you've got a really hot fire, a fire that moves very slowly, then it moves up to the top of the tree, and this can destroy what we call the crown or the middle of the tree, and that's where it grows from. And that can cause permanent devastation. So in order for fires to be effective, it was once thought that you just left everything on the ground and you suppressed all fires and didn't let them happen. And then we figured out that all of the leaf litter and the dead tree limbs and everything, basically that caused a fire that was too hot, because it builds up in there, and if we suppress all these fires that are natural, then that gets so hot, and then that's when we get the tree loss. So now, in order for that not to happen, and fires get too hot, we do what's called a controlled or prescribed burn. And forest officials actually go out and start fires on days where it's not windy, and that helps reduce and keep that leaf litter down. It helps reduce all the dead debris so that you don't have too much kindling. And the fire then just goes relatively quickly, burns itself out, and adds nutrients periodically, but doesn't get too hot so that it hurts the trees. This map you're going to be visiting, and actually I'm having you duplicate it so that you have it handy for you, and also so that you're learning kind of areas of the biomes. I think it's just like doing homework and writing things down, making this map and making it in your own colors. You don't have to make it in these colors, but this is page 118 in your book. And I've asked you to make a key and to find all the biomes so you get a general idea where they are on Earth. biomes are primarily controlled by temperature and precipitation. Where have you heard that before? Climate. So each biome has a climate all its own. And then biomes have usually lots of different interacting ecosystems in them. This is a triangle that kind of helps you take all of the different biomes and put them in perspective. So at the top we have different different parameters on one side. We have temperature, latitude, and precipitation. And as precipitation and latitude decrease, we have dry tropical deserts, but as decreasing precipitation, and if we go up to increasing latitude and also increasing cold, we have tundra. So you're going to read this, you're going to read each one of the sidebars and the horizontal bottom bar, and that'll tell you general characteristics of these biomes. So if we look at, say, temperate grassland, temperature, not too hot, not too cold, precipitation, not too wet, not too dry, latitude, not too high, not too low, so to speak. So we have a Goldilocks syndrome, just right. Vertical zonation, and this is an area, say, we're in the Rocky Mountains, and we talked about this with oxygen levels and the atmosphere being thinner. So we talked a little bit about how that affected as you went up in elevation. Well, also going up in elevation, you can have change of temperature as well. And change of temperature as you're going up and gets colder as you go into those higher elevations, as well as the air thins out. And you're going to see vertical zonation, different ecosystems at different elevations. So you can start out with a grassy meadow down at the bottom of the mountain, and as you move up, it'll get treed, aspens, and in Colorado, around 9,000 feet, the aspens will thin out. They do well from 7,000 feet to about 9,000 feet. They start to thin out, and then you're going to have conifers, or pine trees, basically, 10,000 or the 9,000 feet up to 11,000 feet, which is tree line, and that's what you're actually seeing here. And so you have a different producer at each level, so therefore you're going to have different critters inhabiting this area. This is the tundra, and we're seeing a picture of it obviously in the summer. Climatograms or climatographs actually are a double y-axis graph, and you're looking at two different parameters in relationship to one another. And I am all over top of this, so let's see if I can move myself down here so you can see this. Okay, I did. So basically what I want you to know, and these are important, so, and you will have some of these on your unit test at least if you don't see them on the AP exam. So what you're looking at, the bar graph at the bottom, is the amount of precipitation, and that's shown in the y-axis on your left, and it's shown in centimeters. Then at the y-axis on the right is temperature in degrees Celsius. So you've got January through December down at the bottom, and very, very little rain. And remember, centimeters, 2.54 centimeters is 1 inch. So you've got less than an inch per month, basically, for the entire year. And the wettest months are, you guessed it, July, August, and September. So when we're looking at this, you're looking at amount of precipitation, and then let's look at basically temperature patterns. So notice that even though this is at the top of the graph, look at these negative numbers, ladies and gentlemen, the negative numbers, and we have negative 30 degrees Celsius, negative 25 degrees, and it does get up in July up to about 15 degrees Celsius. And as you see, it's about 15 degrees Celsius, and that's around 65 degrees Fahrenheit. So 29 degrees Celsius is about 85 degrees. So that would be about what our temperatures run, just to give you an idea. There. So the tundra, what are the characteristics? Okay, tundra, it has a very short growing season, little precipitation. This is like a desert, so this is considered a high desert. It has what we call permafrost. This is a layer that it's a layer of soil, and it never becomes thawed out. So plants really don't have the ability to have a root system that is more than 12 inches deep. So since it doesn't have the ability to have roots very deep, then it can't be very large plants. Another reason that plants in the tundra are very short is also tall plants up there would freeze just from the wind factor. So everything's really short, has very, very shallow roots, and most of the vegetation will be a moss-like plant because it tends to be wet. When this does thaw out, when you do have the higher temperatures in July and August, it thaws out, but the soil is spongy and so wet, and so this attracts a lot of mosquitoes and insects, which attract a lot of migratory birds. So it's an area in the summer for migratory birds. Not major area for species diversity. There's only a few animals that are really adapted to take this very harsh weather, and we have two right here, that big seal, and of course our Arctic fox. Now, lots of migratory animals. We have our migratory birds and migratory caribou and elk. This is the taiga. So we're moving down. We were starting really at the North Pole. Think of it like that. And now we are in the taiga, which is just south of that. Basically what we're looking at, if we look at precipitation levels, again, we're in centimeters, and we're up to 5 centimeters, which would be about 2 inches, and annually, just not much precipitation here, less than 1 inch, so we're looking at maybe 15 centimeters over the year. Well, no, 20 centimeters over the year. Then look at our temperatures. We still only have this high, 15 degrees, but look at our lows. Our lows aren't quite as bad. We're not dipping down in there to the negative 30s quite. So the temperature is a little bit more mild here, and there's a little bit more precipitation. This is the taiga, or boreal forest. This is the largest biome in the world, meaning there's more acreage of taiga than any biome. Primarily for human use, we use this for trees. And so they're cut down so that we can have wood products, paper, that kind of thing. Again, very, very short growing season, and it's very cold. However, the soil does thaw out, and we can have trees at this point. Most of them are conifers or pine trees. Pine trees have the ability to absorb, or not absorb, conserve water. It's the way they're made. They have needles instead of leaves, so they lack surface area, so they don't lose a lot of water. Their needles are covered with a wax, so it prevents water loss. Their shape, they're made like a Christmas tree, but when it snows and the snow is on their branches, and their branches will drop the snow right at their root base, so that as it melts and that snow slides off, all that water is going right around the roots. So kind of a nifty little plant there. And conifers are not just one type of pine tree. There's different ones. There's spruce and fir. Also, there's a few deciduous, such as the aspen and the birch, but mostly the conifers. Now, conifers are unique in that when they drop their leaves create an acidic soil, so the pH actually goes down. And when you go into a pine forest or an area that's just conifers, nothing else will grow because the pH level has dropped so low. And you go into these pine forests, that's all there is. And it's a surreal feeling when you go deep into one, because it blocks out all sound, and you can't hear anything. It's very, very, very quiet. Kind of a cool experience. Animals that habitate moose, lynx, migratory bird, insects. So these are all winter hardy animals. They use the tree surface for protection, housing against the weather. The moose eat grass, and so they'll migrate to grasslands. The lynx, he'll hunt out in the open, but he'll use this again as an area of refuge. Our next is the temperate rainforest. Now look at the difference in levels of precipitation. Lots of precipitation, 18 centimeters of precipitation. But notice the dry season here is during the summer. Then I want you to look at something else. Not a huge dip in temperature. Temperature stays very mild. 0 degrees, and 0 degrees is 33 degrees Fahrenheit, or around 32, and so not really freezing. Now, the only temperate rainforest that we have in the United States is up just north of Seattle, Washington. So it's an area that is located close to the coast, so it gets lots of moisture from the Pacific Ocean, hence all the rain. And because there's so much humidity in this air, there's not a great fluctuation of temperature. Still not getting tremendously warm there, barely 70 degrees, but still cool. Has many evergreens, but also we're adding some different species such as hemlock and cedar. This area has a high biodiversity because it does not get very cold, and the temperature range is very mild. Anywhere we have cool in the last three, the tundra, the taiga, or the temperate rainforest. Anywhere we have this cool temperatures, you're going to see decomposition rate be very slow. So that means that nutrients aren't getting put back into the soil as fast. Especially when you have a time period where it freezes, that's going to cease decomposition. So this, you've got decomposition going all the time because it doesn't really freeze, but it slows them down quite a bit, their metabolism. So there's a lot of leaf litter. These are forests that we call old growth virgin forests, which means that they have never been logged before. These are original trees, and they're actually protected trees, and so they cannot be cut down. A lot of time what happens with cutting the trees down, we're using selective cutting now. We're not going in and clear cutting, but when they replant the same species all through that area, and that's really not good for the ecosystem. And by not having that biodiversity, disease can go through the area very fast, and then we don't have biodiversity of our critters that live there either. Okay, I believe this is the first slide of part 2. So we'll stop there. Go ahead and check your knowledge, and stay tuned for part 2, chapter 6.